Yay. A chance to consolidate our knowledge, right? I could do a review session sometime Thursday morning before 10:30. Is that possible?
Yeah, that works.
Don't people have class Thursday morning?
I do.
Starting at 9?
Yeah.
So we could start at 8:30, so you could get the first half hour. Is that good? Okay. So 8:30 Thursday. And you know, it'll just be, I don't have anything planned. Just I'll be there to answer questions.
So it'll be in 2000 in that other room?
Uh,
How long do you want the room for? And I'll ask Penny.
Maybe till 10. I doubt if we'll go that long, but that's probably good. Okay, so Taya will let us know what rooms she has secured. I would like to at least tentatively set up a class at the end of the month, because we won't be able to meet on Memorial Day. So let me try out some dates. One would be Thursday the 24th, either morning or afternoon.
The afternoon is Stella's class.
Afternoon is fine?
Just Stella's class.
Okay.
That was Thursday the 24th.
Thursday 24th.
The morning is better for me.
Okay, but you have a
I have class
starting at 9 again?
Yeah,
And running until noon?
right. But if it's for me, then I could, if I make this video.
Well, let's try another time. For some reason, I have the 30th Wednesday marked as UCI holiday.
It is?
Oh, that's fantastic.
Also should be.
No, it's not.
No, it's not.
Okay, well,
Just killed my hopes and dreams right there.
what about class
Well, hopes and dreams, man.
that day?
We have our qualitative methods class from 9 until noon.
And we have an ed policy makeup class from 9 to noon, but we could do it in the afternoon, right?
Works for
Yeah,
me.
my policy.
Makeup, yeah.
1 to 3 on the 30th?
I may have a
I
conflict.
can't be
Yes,
there,
you're right.
but
Yeah, I may have a rescheduled class. But I can try to make it.
Okay, let's say 1 to 3.
you will be missing a speaker, a decade speaker series that day.
What?
Starring one of our.
This is
other
Marta
faculty.
Tienda?
Yeah.
But she talks at 10:30.
10:30, not 2:30?
I have her down for 10:30 in the morning.
Okay, I have to check. I think I have 2:30, but I could be wrong.
Okay, please do,
Okay.
because we could start at 12:30 to 2:30, right? So hold early afternoon on the 30th. So nothing on the week before. And then the review session this Thursday.
It is, I have 2:30 to 4 for Martin Tienda.
Huh, okay, so how about 12:30 to 2:30? 2:20, 2:25, for those who wanna go over.
Wait, it is 2:30?
The talk starts at 2:30.
So it is,
12:30 to 2:30.
May 30th?
Yeah, May 30th, 12:30 to 2:30. And again, yeah, you can get a room, please. Great. Okay, let me again ask if anyone's interested in an ECLSK workshop, how to use the data. Can't imagine you shouldn't be. It's a great data set, you know, it's got the evolution of literacy and mathematics achievement over the course of elementary school. It's got computer questions home and in school. It's got all sorts of classroom practices, what kind of teacher practices there are in the classrooms. It's good to learn several data sets during your graduate school career. You know, even if you focus on a very specialized one, it's good to have knowledge and practice in some of the bigger data sets. So, you know, unless 4 or 5 people are interested, probably not worth setting up something. So let me know by email if you're interested, okay?
Can we just raise our hands right now?
What's that?
I said, can we just like raise our hands right now?
Well, no one needs to ponder further. How many people are interested at this point? All right, so that exceeds the minimum threshold.
Greg, I just found another place where it says 10:30, so I need to check.
Okay.
Because I got an email personally to me that said 2:30, but then on the grad calendar it says,
Yeah, the general announcement I saw said 10:30,
okay,
but it could be 2:30.
Okay,
10:30
I'll let
seems
you
like
know.
a strangely early time.
yeah, it does.
Okay, any questions before we start out? So this is well, let me tell you about the exam. Might as well. I told you a little bit before. It's fun. It's, right?
Yeah.
I can say it's fun.
Absolutely.
It'll be the second half of class, and you know, think about what the goals of the class are. They're to enable you to understand what regression coefficients mean when they're in tables and articles, and so there may well be some regression type results that would appear in an article, and you might be asked to interpret coefficients. We've had, you know, I've learned about various kinds of nonlinear equation forms, dummy variables, quadratics, logs. Each have their own little twists and turns in interpreting the coefficients. We've had logistic regressions, right, to handle dichotomous dependent variables, and that has its own tortured logic associated with it. We've done a little bit on path analysis, so that's fair game. You know, it's really just standardized coefficients. We talked about elasticities, different kind of interpretations to coefficients. So it's really just the stuff we've been going over so far. You know, what we'll do today is won't be on the exam, but everything up till now will. People seem reassured if they can bring a single 8.5 by 11 piece of paper filled with whatever they want to fill it up with. You're welcome to do that. I would advise you to not spend too much time filling up your 8.5 by 11 page, because that kind of work generally isn't as thoughtful as reflection on what we've been covering. So make sure you engage in deep thought as well as very small handwriting in preparation for the exam. Calculators, they provide some measure of comfort you can bring. You won't have to use them. And you should have enough time to finish up, because I'm not so interested in speed as thoughtful reflection on the succinct answer to the questions that I'm asking. So this is not an occasion for mind dumps, to spill out everything that you've learned about something, even if it has no bearing on the answer to the question that I'm asking. So these are, by and large, pretty short answer type questions.
Will there be definitions?
Well, you know, standardized coefficient. be able to explain that, I guess that's a definition, right, or an elasticity or something like that, so. That's certainly fair game. Any other questions?
Is anything on Stata gonna be on the test?
I'm sorry?
Stata?
No.
Would you say the test is more, I guess, theoretical and based, or more of application data, like what we did for the lab homework?
You know, the lab asks you to interpret coefficients, right? Write up a little, you know, half-page summary of what a given set of results mean. That's certainly fair game. You know, it's all about, can you really understand what someone is trying to convey to you when they write up the analysis in an article.
Is everything in Woolridge fair game for the exam? Because there were some topics covered in class that weren't covered in Woolridge and vice versa.
What's in class is what's going to be on the exam.
Okay.
Yeah, Woolridge covers a lot of other stuff, right?
Mhm.
So, it's much more extensive than what the exam would be. And it's much more formal too, it's not really stressing kind of intuition in the same way I am.
So that's the same for the other text as well, like.
I'm sorry?
So that's the same for the other text?
Yeah, I mean, the
as
other
well?
text is a little bit more intuition based, but both are more background to fill out what the lecture doesn't go into detail about. And they're different levels for understanding statistics. And with Woolridge, it's a very formal kind of level, right? Everything is laid out very clearly and derived and everything. You know, with the Gordon book, it's a little bit more, quite a bit more practically oriented. She does a lot of examples from articles, and tries to connect it to, you know, the state code or SAS code, and that's good. But, you know, it's important to be able to work through those kind of processes, but in the end, what I really want is this kind of intuitive understanding of what you're reading. And we'll go over some examples of that today as well.
Are you gonna ask us about about articles that we've read in class and like what they, to recall, like what they found or anything like that? Or are you just gonna have like, here's a table and like interpret these numbers?
I won't ask you for a coefficient on a table that I don't present, but you know, it might be some finding from an article, and I'll list the finding, and it will help to have understood what the article's about. You know, the Levitt and Fryer, for example, that's, there are any number of interesting numbers from that article, and to be able to understand, especially the numbers that we were trying to focus on, you know, the gains and gaps. That was the important part of that article. Any other questions?
Is it too early to start talking about the first paper, the natural experiments? It's 2 weeks away, a couple weeks away, so. That's fine.
It's slightly too early. You know, we're, there's kind of two parts to the course. One is trying to understand what a coefficient means, and the second is to understand whether it's worthwhile trying to understand what a coefficient means. You know, which is to say, is the analysis set up in a convincing way to approximate an experiment? Remember we talked about causality. Or is it so fundamentally flawed that it's just not worth trying to understand what the numbers mean, right? And now we're trying to transition into the second half. And natural experiments are one way of setting up an analysis design that provide a more convincing causal estimate than would be the case if you didn't have some kind of natural experiment, right? So, today we'll talk about, issues of causation in the context of Hanishek and Raymond and, Wong and Cook and Barnett. And so, by next Monday, I think you'll have a better idea of what natural experiments might be about. And so, I think if we talk about the assignment next week, it'll make more sense. Okay? All right, so now we're finally getting into the heart of the course. There's been a lot of preliminaries. Let me, so this is trying to focus on whether the numbers in the tables are worth spending any time on, right? So is the analysis set up in a way that provides a convincing estimate of, or a convincing test of the hypothesis that the paper's trying to test. And it's good to start out with Raymond and Hanishek. They're interested in whether two kinds of accountability systems in states actually affect what students learn. Now, it's hard to think of a more important policy topic these days than does accountability make any difference at all, right? So they've gone through and categorized states according to what sort of accountability policies they might have put in place at different points, mostly in the 1990s. Some put in policies that they judged to be a consequential accountability, that they really had penalties associated with them. Others put in place report card systems where they would grade schools or school districts, A, B, C, D, but didn't really have any consequences attached to them. It was just kind of information. So this is their basic table. Look at the first column. That's the basic results. What does the 3.24 number mean?
What's the scale for accountability and what's the scale for the dependent variable?
What did your reading tell you?
I forget.
Accountability was 1-0. And these are NAEP, Reading and Mathematics Performance Scores. If you look to the appendix, you can see the descriptive statistics. Consequential accountability, proportion of period with school accountability having consequences for the school. These are 4-year periods, so if the school adopted accountability and midway through, it'd be 0.5. If it was there all the time, it'd be 1. If it was there none of the time, it'd be 0. And then down here, you've got the NAEP scores, 8th grade scores for math and reading, and the standard deviations are 16. Okay, so if we go back to our table, all right, so now you're ready to tell us what 3.24 means, right?
Period of time of accountability, in which you have 3.24 standard deviation.
that seems like a big amount, doesn't it? So the standard deviation was 16 for this measure. So we're moving only 3.2 points. So it's gonna be about a fifth of a standard deviation or so. In going from a 0 to 1, which would be a 4-year period with no accountability to a 4-year period with complete accountability. And then same way with report, and it's a T ratio underneath 3.0. You can see it says at the bottom that T ratios are
Absolute value of T
absolute value of robust T statistics. The clustering for state in parentheses, so that's a highly significant result. In contrast, report card systems that scale the same way, what fraction of years over the 4-year period of change are there? Is there a report card system in place, and going from a 0 none of the time to a 1 all the time is associated with a insignificant impact on test scores? And then there are other control variables such as school spending. You know, having, this is $1,000 per pupil. If states on average increase their per pupil spending, what's the average per pupil spending in the United States? To the nearest $5,000.
12,000, 10,000.
It's 8 point something thousand, right? So that was close, that was within 5,000. So if you go from, say $9,000 to $10,000 per pupil expenditures over a 4-year period, it's associated with an insignificant change in test scores. They're worried that that schools game the system and exclude special ed kids or English language learning kids from the exam. And it's true that if you're a state that's actually changing your exclusion rates, there's a significantly higher score that you have. So if you're increasing the exclusion rates, excluding more kids from taking the test, then the test scores for those who do take the test are going to be higher by half a point. That's a significant result. Okay, and then they do things with across race and ethnic groups and what they call minority exposure. But let's just concentrate on those numbers for the time being. All right, so looks like consequential, by this analysis, actually having an accountable policy system in place is associated with significant gains in test scores. So that's an important result to inspect, to try to see if it makes sense, if the analysis makes sense. What sort of threats to the validity of this result can you think of? Why might this kind of look not really give you an unbiased estimate of state accountability practices? Because
Well, one state accountability system is very different from another state, and one altogether.
so they might be very heterogeneous one from another. So you might want to look. I mean, they do break it down in this dimension, right? Some states are going in a weak kind of reporting system policy regime, and others are going toward more consequential accountability. So, but even within consequential accountability, you might want to break it down by type of consequential accountability.
Why would they have done something like that?
I'm sorry?
Why didn't they break it down further, the consequential accountability?
Um,
Or did they?
Well, it's, can't remember if they did a lot of extra stuff.
Doesn't clustering by states adjust some of that variance across states?
It's adjusting for the fact that if you've got the same state observed several times,
Right.
then, those observations aren't as independent from one another as the observations in different states, right? So that's not about bias, right? It's really just about
Right.
the standard errors. In a way, you do wanna have, you wanna have your results be as general as possible. So even though you have heterogeneous accountability systems, if on the whole, results are pretty similar across different kinds of accountability systems, if you get into all the details, then you kind of lose the basic point, which is the hypothesis is that accountable, consequential accountability systems improve students' test scores. That's the hypothesis. But I think they are unable to break down the consequential accountability further. You know, you're taking advantage of the fact that certain states are adopting this at certain times, and there's only so much you can disaggregate. Okay, but that's a potential problem. There might be a lot of heterogeneous impacts that are getting averaged together here. It shouldn't be a biased estimate from that, it should just be an average estimate, and you're saying you really want more details, right? Why else might you not want to believe that?
Could you argue that states that have higher accountability systems are also doing something differently in terms of curriculum or schools in teaching that would also cause growth in test scores?
Exactly. I mean, that's the primary threat here, that there are omitted variables in this analysis, other kind of practices that schools might be putting in place at the same time that are really responsible for the increase in test scores and not the accountability. Right? And that's especially a problem if states are really serious about improving their school systems, they might be putting in some sort of accountability system as well as a new curriculum and enforcing or providing support for a new curriculum and in other ways trying to improve the schools. They might be increasing spending on schools, but that's controlled, right? So it's not that. But there might be other things. It's really hard to, and we'll talk about how they set up the analysis to try to address that. But you might not believe that they've controlled for everything when all is said and done.
These are states that had accountability systems before NCLB.
Before,
NCLB?
yeah.
Okay.
I mean, this is all 90s stuff.
Okay.
So states were doing a lot of things on their own, which is often the case. Okay, so let's see how they end up getting this result. And alright, so how do I zoom in? Control plus?
Yeah, that seemed to work last time.
Alright. I'm not an Apple kind of guy. Alright, so there are a lot of things not to like about economists, but at least they, in their empirical articles, lay out their assumptions. May not like the assumptions, but here goes. So instead of just diving in, they say, well, let's think about how accountability theoretically should figure into student outcomes. So they start out, consider a simple model of achievement, such as this. O is the level of student outcomes in state S at time t, right? O sub st, that's the achievement score in state S at time t. And that's going to be a function of family conditions, other kind of non-school conditions in that state at that time. It's going to be a function of school resources, the kind of stuff that Kelly was talking about, not accountability, but other things that schools are doing that are going to affect kids' test scores. And then policies for that state, right? And accountability is going to be one of those policies. But there are other policies as well, so we want to allow for that. So it's hard to argue with that statement. They say to make it a little bit more tractable, instead of a general functional form, let's make it linear. So it's just taking that and having it be linear and additive, and then adding some sort of error term on here that if we haven't measured policies directly, the error term is going to consist of both the policies that the state adopts and other things that are unique to that state at that time. And they make the point that, the regular omitted variables point, that if you're trying to relate some sort of family factors to student outcomes or some kind of school resources variable to student outcomes and have not controlled for policies, then you risk omitted variable bias. But we're interested in accountability as such. So they add accountability. Now consider just adding a measure of whether or not accountability perfects incentives and thus student performance. So it's the same thing we had before, except accountability in state S at time t is explicitly entered in as a variable because we're going to have measures on that. But then there are still other policies, school policies for that state, as well as an error term. All right, so far so good. Now, they do two additional things that make their analysis much more convincing. As long as they're back here, where accountability policies in a state at a given time are being related to student outcomes in that state at that time. The scope for omitted variable bias is enormous. You've got some controls for what that state's doing for resources, some controls for what that state's demography looks like. But just having accountability here, there are 100 things that distinguish states that have accountability policies from states that don't have accountability policies. And you have to really worry that those things are what's determining student outcomes. And if those other things aren't measured and controlled for, then it's going to look like it's the accountability policies, right, that are affecting student outcomes when in fact it's a bunch of other stuff. It's kind of the classic omitted variables problem. So what can we do? Well, one thing we can do is look at this equation as changes instead of levels, right? We started out just looking at an outcome in state S at time t. Now let's look at changes in that outcome for state S as t goes from t to t star. Right? In particular, they take a 4-year period of change, which is a period over which they can get NAEP score data. So they're looking at 4-year changes in achievement scores for a given state as a function of 4-year changes in demography, 4-year changes in school resources, 4-year changes in accountability, and then an error term. Right? So we'll talk more about this shortly, but what that does is bring all the analysis within a state, which is really a huge step forward. You know, back here we were comparing different states with different accountability systems and their outcomes, and there were all sorts of cross-state differences that might be omitted variables that are biasing this relationship. If we talk about change within a state in outcomes as a function of change within that same state in terms of accountability, right, then all the action is within states, not across states. So there still might be some omitted variables, but it's got to be, you can't argue that you know, Iowa has higher test scores not because it has accountability, but because it's got a bunch of farmers. You know, farmers have this work ethic that gets transferred into support for accountability systems, and its children, I'm one, end up with okay test scores. And states differ in terms of the number of farmers they have in the farming mentality, right? If you estimate the change equation, the fact that different states have different kind of farm-related mentalities doesn't figure into any of the variations you're trying to explain. You're now looking only within Iowa across time, right? So any sort of state characteristic that's persistent isn't going to be biasing your estimate of accountability because it's all within the state of Iowa, right? And you can think about this across 50 states as being looking only within each of those states at the relationship between accountability and outcomes. And so cross-state differences aren't going to figure in. They get differenced out when you do this time change. All right, so that's a huge advantage. Now, let's see some puzzled looks.
I have a quick question.
Sure.
When do you use the random effects model versus the fixed effects model?
I never use a random effects model. I always use a fixed effects model, and fixed effects are the next thing we're going to talk about. I mean, in a way, this is, well, hold that question for about an hour and let's see if we answer it, okay? But does everyone see what's going on here? All right, let's see. What appeared to be looks of puzzlement turning into head nodding, so I'll take that as seriously. We start out with point in time, looking across states, and now we're doing a change within state. And that's huge, because any sort of cross-state differences that we can't measure that are persistent, they're no longer affecting our estimate of changes in accountability within a state affecting changes in student outcomes. Yeah.
Is this called value added?
This is a form of value added. Value added models are usually classroom specific or school specific, right? Where you're looking at test scores last year versus test scores this year. But it's the same idea. It's the same idea.
So
Yeah.
I get this, but I don't understand how this is helping with the problem Kelly identified. 'Cause how is this saying, well, maybe the state just changed the curriculum practice? Is that still within the state?
It's not changing Kelly's problem. It is addressing a potentially broader class of biases.
Okay.
But you know, if states had certain persistent policies, then it would get right. But it's just if policies happen to be changing at exactly the same time, right? Then this isn't going to solve that problem, right? All right, but wait, there's more. So now we're adding what they call a state fixed effect. And a state fixed effect, and again, we'll talk about this after we work through this example. A state fixed effect amounts to putting in a dummy variable, a set of dummy variables, one for each state. And why do we want to do that? You know, we're already looking within state across time, but suppose we've got several different change periods for a given state. Okay, so in fact they've got 2 4-year change periods observed for every state. You can only become accountable once. You can only adopt a consequential accountability system once, although you could drop it. I'm not sure any states did. So you might have, let's say if you've got 2 consecutive 4-year periods, it might be that during the first period a state went through its 4 years without adopting accountability, but in the second 4 years it adopted accountability. All right? So states might differ not only in the level of these difficult to measure variables, but also in how they're evolving over time. And it's even more powerful to go from this model, which is just one set of changes over 4 years, to be able to say whether a state that adopted accountability in the second 4 years experienced faster gains in math in those second 4 years than it had over the previous 4 years. Right? So you have gains before for that state. You've got gains in the second 4-year period, which is a period when accountability was put in place. You know, maybe the state is going great guns and was gaining rapidly anyway. So you really want to know whether a state that's gaining rapidly in its test scores is gaining even more rapidly when you put in accountability, right? Or a state that's stagnating or falling is arresting that stagnation or drop by having accountability policies. So it's good to be able to not just look at one change for every state, but to look at changes in changes, in effect. And that's what this dummy variable for state does for you. And I'll try to make that clear on the board after we work through the article. But be aware that this simple change and then a fixed effects adjustment in this case are two different things, and this adds an additional level of control that just a simple change doesn't. Okay? Questions? That's the equation that they end up estimating. So when we saw the 3.24, I think it was, you know, it was that states undergoing a 1-unit change in this accountability system, in other words, going from, they've got these 2 4-year periods. If they went from a 0 in the first 4-year period to a 1 every year the second 4-year period, that would be a 1-unit change in this variable. And they want to see whether the growth in math scores, the growth in reading scores for that state in the second 4 years is higher than the growth in reading or math scores in that state in the first 4-year period. Just because they went from 4 zeros on accountability in the first 4-year period to 4 1s on accountability in the second 4-year period. The proportion of years that were accountable was, in that example, going from 0.0 to 1.0. You know, a state going from 4 years of no accountability to 2 years of accountability would be going from a 0 to a 0.5. And so you would be estimating a half a point. You'd have a half a point observation, even though the interpretation of this would be what would happen if you had extended that half a point to 1 full point. And it's estimating that growth, that differential growth, separately for each state, and then getting what amounts to an average growth in test scores associated with adoption of accountability. And they still have the potential Kelly problem, the famous Kelly problem, which is the quintessential problem. They put in additional policy variables explicitly that might be changing over these periods of time to try to account for as much other policy change as they can. But you've got to ask yourself whether all of this differencing provides a convincing estimate of accountability policy change. Now, one thing that's nice is that they use NAEP scores. NAEP scores are never used for the consequential accountability. It's always some state test, right? The CST or something like that. So this, sometimes people who do these accountability studies have both the consequential test and something like a NAEP, which is an inconsequential test. And you usually find bigger impacts on the consequential test, but this analysis only has the NAEP scores. So we're really just looking at what the impact seemed to be for a test that was not used to assess accountability. All right, so one question, do they really have enough variability? To pull this off, this is 1993 to 2002, and you can see, you know, this No Child Left Behind came in 2001, right? It was passed in 2001. You can see how states were doing. This is the number of states. 40 states by the year 2000 had done either a report card system or had what they considered to be consequential accountability. So there was a lot of action, and they actually list the states and the times that they acquired either consequential accountability or report card accountability. So that's their data set, essentially. And Another thing that's nice, so they have NAEP data, I think it's math at 1992, 1996, and 2000. Right, 4-year intervals. And NAEP scores, you know, they do NAEP testing for 4th graders, 8th graders, and 11th graders, 12th graders. I don't know what the oldest one is, but they just take 4th grade and 8th grade. And so they define these 2 change periods, 94 to 96. And for that, they go from the 4th grade scores to the 8th grade scores. So it's the same cohort of kids, right? They're asking whether that same cohort of kids is growing in math more in accountability states rather than no accountability states. And the same thing for 1996 to 2000. They go from 4th grade to 8th grade. And then, as I say, it's this difference in difference. They want to know whether the change, say, between 96 and 2000, 4 states that adopted consequential accountability, right? So Nevada, Oklahoma, and Tennessee adopted consequential accountability in 1996. They would have had a 0 on the 92 to 96, and then a 1.0 fraction of years between 96 and 2000. That there was a consequential accountability. So they would have gone from a 4-year change with no change in accountability to a 4-year change based on full-time accountability. And that's the variation that they end up using to estimate their models. You can see the kinds of variables they have. And again, the results. Right? So it's the kind of superficial coefficient interpretation is a consequential accountability going from none to having consequential accountability is associated with 3 points on a NAEP scale, which is about a 1/5 of a standard deviation. But once you dig into the article, you can see it's really that states that went from a 4-year period with no accountability policies to a 4-year period with full accountability policies changed their reading and math scores by 3 points more than states that stayed inconsequential. Controlling for changes in all these things. Questions?
So would another follow-up study be how much time, resources, money went into implementing these accountability systems, and then what is it worth, the 1/5 of the standard deviation?
If you're doing kind of a cost-benefit analysis, yes. You're an economist inspired. You have to ask whether it's worth it, right? 1/5 of the standard deviation. And there's certainly a one-time setup cost, huge, right, associated with putting this in place. After that, there are probably some ongoing costs. But yeah, you've got to ask yourself whether it's worth it. Some of that money's probably reducing the amount of money you have for instruction, right, and other teacher salaries and things like that. So that's exactly the question I ask: is a 1/5 of a standard deviation worth it? You know, if you believe this, the report card system results seem to indicate that the smaller effort associated with putting in a report card system doesn't look like it's worth it.
Greg, good to know about test scores, but we focus on test scores for a very specific reason, not necessarily the goodness or the interesting part of test scores, but because test scores predict these other things. So I think it would be more useful from a policy standpoint to know that if this consequential accountability actually affected more tangible things in the future.
I couldn't agree more.
Okay.
So now, you get into these issues about whether you could actually use this kind of estimation scheme or any other kind of estimation scheme to really nail down impacts of accountability on those kind of outcomes, right? So I completely agree that you really want to know about graduation rates, college attendance rates, and things like that.
Cause it just doesn't seem like the NAEP scores of a 4th and 8th grader doesn't really mean much. I mean, it means a lot in a certain extent, but it doesn't really mean much in terms of success later in life.
Well, there are studies linking test scores to dropping out and attending college, right? And they show, especially for math scores, that you get these associations with both completing high school and going on to college. So you could bring other data to bear on interpreting these data. Or you could think about, some other research design taking advantage of this kind of variability to estimate consequential accountability. You could think about a national survey of some kind that told you in what states kids resided. If it's a longitudinal survey following kids from kindergarten through, say, age 21, you would be able to measure what fraction of their school time was spent under a consequential accountability regime, right? You could actually see in what year, suppose you had kids who were turning age 21 in 2005, right? Between ages 5 and 18, if you knew what state they were in, you could see what fraction of the years between 5 and 18 they were in a consequential accountability kind of scenario. And then you could try to see, controlling for tons of other things about the states as well as the families, whether or not that fraction of school years spent in an accountability state was significantly related to high school graduation or college attendance. You've got to ask yourself, would that be, would you believe that number, right? Is that likely to be as unbiased as these numbers are? And then the trade-off becomes, it's a much better outcome, it's an outcome we care about a lot more, but is it going to give us an estimate that we believe in as much or almost as much as we might believe the estimates that come from this article? But that's exactly the kind of question to ask. And then, the next question is, what kind of design involving data on state consequential accountability and graduation rates, college going rates, what would be the most convincing research design to try to make those links?
Because what would it mean if there's this link between consequential accountability and NAEP scores, and there's a link between NAEP scores and graduation rates, but there have to talk about those two relationships sort of separately?
Well, it's kind of a mediating model, right? You can think of consequential accountability and then graduation rates, maybe with test scores in between. And one route might be through test scores. You could think of a lot of other routes. It might be through behavior. Consequential accountability might be, setting high school exit exam standards that are going to actually reduce high school graduation or college going. There's some evidence of that. But if the total effect isn't there, if consequential accountability isn't affecting graduation rates, then it hardly matters what those intermediate links are with test scores. It's got to be some combination of either consequential accountability not affecting test scores or test scores not affecting high school graduation, or maybe other things going on that even if that's a positive path, there's some negative path like high school exit exams leading more kids to drop out. But it's best to try to nail down the big picture before trying to look at the intervening pieces. So you could estimate this proportion of years spent in a state with consequential accountability with data that Ken Lee knows a lot about. Tell us why.
No. I hate the data set right now.
He's learning, I should say. But there are these data sets that would enable you to do that. Any other questions? It's awfully warm in here, isn't it?
Yes.
Yeah.
I wonder why they don't
There's
have
a fan right there.
What?
There's a fan.
Oh, excellent.
If you open the door, it's cooler.
Yeah, well, let's take a break now and open the doors, turn the fans. Just gonna get Daryl to turn on the
Well, what? I will put coffee.
Yeah, coffee.
For what? Oh, yeah, I saw 3 shots of espresso. That's how I start my day.
That's what I need.
So spirited.
No.
So what? Spirited?
Oh, yeah.
I'm not sure what you mean.
No, saving money, put it aside, or camera, live fast. Not good, that's quality is better. I know what you mean. She wakes up at 12. You're gonna buy some. She makes me coffee in the morning. I wake up and like espresso. What is really nice. And it's not, and it didn't drop that much. It dropped like half off. It didn't drop that much. Yeah. I get it. You want the best.
Yeah. But like this
He's interested in her because he used to tutor playful students.
You used to tutor?
Playful. The English proficiency thing.
Heard about it in Santa
It's really hard to get the amount of tutoring that time on college.
They have ESL time.
Not just that. No, I could get like 100%, but I saw
learning the language is very
it's like junior high school level.
I'm very sympathetic because I tried to learn French, and after years and years, it's like, oh, I don't understand.
Yeah, I know.
I took learned English and Spanish very well, but those are hard. And I know those
Easier
are
when you're like immersed in it. So if you're just taking it in like a class and you're only immersed in it like 1 hour a day,
well, it depends who you talk to. Because the Spanish that my family talks is not really very helpful when it's ever. And to learn a lot of stuff.
I've been studying a lot about
Even like the Spanish you did is different from the Spanish you use mechanic.
Of course. Well, it's like English.
Oh,
like
yeah,
if,
right.
you know, it's like if you speak regular, just dialect,
Just a few
slang or a few words,
Yeah.
and you're never going to talk about research in a regular conversation.
academic language.
Yeah.
Yeah.
So it's definitely different.
That's a huge part of ESL studies and stuff. It is apparently you can get conversational stuff in a year, but academic is like 5 or 6 years.
Yeah.
Because you never run into these words. So,
I had to read a lot of Spanish articles because I was teaching a class on how to read research with people that never done research before. That was really helpful. That was I learned a lot. It was very stressful. It was from a GSR, but it was
it might help a little bit that a lot of them are Latin-based. So at least like, you can kind of bend it a little bit so that you can guess what the word means.
yeah.
I found that to be the case at least when a friend of mine was doing the TSR. She kept having, she kept knowing a lot of the words that like, she probably never ran into, just because of the root was like the same as Spanish.
Yes.
She still bombed it. She bombed it, but for the GRE it was great. But
You gotta know what you're doing with it, because I've had friends who are bilingual, but they know how to do that. And to me, I get so nervous that I don't know, because there was a word, and I was like, I have no clue what that is. And I looked it up, and I was like, that word sounds familiar. If I had just said it in Spanish, it was exactly the same thing. But I was so nervous, like, I don't know
the
this
GRE
stuff.
has a tendency to do that. I think that's why she bombed. But no, that happens.
This weekend,
Very often.
yeah, surprising my mom.
Yeah,
my dad
words
knows.
in there.
Well, you know,
I'm gonna use them.
But I just, I guess I could.
this, well, here's a good example. This cohort of students from the department who upped our theory sentence, I think. And none of them are like,
No, they're
My mom, she'd be bummed. I was like, no,
pretty much. So that has a lot to
I
do
mean,
with
the moment that happened, I heard about it. It's,
that. Yeah.
we don't really know.
Depressing. I don't take theory very
Well, they accepted one girl that was Hispanic, but she
She
didn't.
didn't accept.
She didn't accept Islam. One Latina girl, Jennifer, and I think they were allowed.
Until I started dating my boyfriend.
So it happens. I don't know why we want to up the theory scores except for maybe trying to raise our
Like one person will be like, that's
national ratings. Because we use that in
upstairs in their room.
But
objective.
Never knew that was weird. And I was like,
but it only accounts for like a small part of the reading.
Oh yeah.
Families are just quiet and boring.
You just want to yell.
We probably raise the subjective rating a little bit if we actually started working different groups, but whatever. The department has their own agenda, so.
I've heard there's a lot of arguments
Oh yeah.
to ignore the GRE.
Oh,
And I feel like I just have to keep
Well,
doing
you
it.
know,
That's the
UCLA
only
doesn't
way I
put
learn,
too
is
much
like over and
take
over.
theories too seriously because they acknowledge the fact that a certain group of people tend to do this well. I happen to be in that group, which is very fortunate for me. I don't know crap, but I'm really good at the theory.
I can only do well in the math.
Yeah, I think I'm just a good test taker. Because I don't stress under the pressure. I'm used to getting in the 99 percentile for no apparent reason. No, not cool.
Well, it helps you.
It helps. I mean, I even got a scholarship because one year they were rewarding kids if they did well on their standardized test during school. I think it was NAEP or something like that. And you know, yeah, they did well. But those the way you take a test is like a different
Teachers would never
different strategy and stuff that people don't always implement.
Well, it's easier for math because I did practice with the test, and there's a lot of perspectives. It's supposed to be like really basic, like the point of sense, right? And I did like writing and stuff. Just for the vocab, the connection between words.
Answering quickly is definitely a huge part. part of it. Because well, I was also one of the parts of being a good customer is being able to answer quickly. That was another thing.
So logic.
Always finish in like 15 minutes.
I'm used to tutors.
How you doing? The math is
The first part? What happened? What happened?
What do you mean?
What were you saying about the
I said you can do
No.
Yeah.
You do that.
We just try to teach people
So you must have been really good at that.
Yeah.
Okay. That's probably yeah, it was the reason I had
They trusted you? Oh my god.
Why should I?
Okay, I know, take the test first, so how you do it.
Yeah. I don't know why. Well, I apparently.
They saw the genius.
I don't know. So what was this? You know,
Go in the morning, but then after sweat and then
I'm
shower and
very,
then back.
very.
What, like, what units are those?
So you gotta check and make sure this isn't interfering with the. I don't know if it's interfering
They
with.
always have. I think it's
No,
very
with the
fine.
sound.
It should be fine.
Okay.
It should be fine.
It's old. It's like, got a smart ordinance.
I never responded. Yeah. We'll probably start a little after.
How did I do
Right now, do I do anything now?
GRE?
GSI.
Oh, no. I have a GSR. I have a fellowship, so I have a T-shirt for it.
She just goes free market.
Yeah, I know. Would you start at me?
It's very important.
No, that's actually the vision. I guess. I didn't know
We just did it after.
But I know,
We have you. You might have to know what it is.
Why?
Like,
So those
Stand by twice.
I don't know.
they didn't
You
know
get the
because
month,
because
it's Friday.
three
But then I think some sort of
classes and then
your score on the test
fourth
score
year
or
I work, so you have more free time. I'm assuming that's their logic.
That makes sense.
Yeah.
yeah.
Because you're, you didn't take up much.
That's many classes.
It was like much better than that.
Yeah.
My neighbor had her English was saying that.
Ask for
And it was
logic.
like,
Yeah. No, I told her, I was like, look, if she sucks, like, she can like, I should have BS about other stuff that.
So it's like
everybody else.
Yeah, I doubt you do. But like, worst case scenario, I'll tell them like, you need like more practice teaching.
no, well, they
Take
do.
all
I
that for like,
Training
training is, they tell you like strategies, techniques. It's not really much, it's like, well, good to see other teachers and see how they explain problems. Cause like, you only saw me explain problems, and I skipped it. I kinda skipped that a lot.
One
You didn't?
sister who was doing something and
Well, that was just Francesco.
my mom wanted to see it. She would have like, I would have been good with
Did you see my math?
They just spent.
Yeah.
I was like, no, they like.
Right.
Yeah.
Well, it's a first date.
No.
She's like super bad.
Yeah.
But it was really important to me
I saw her score.
because I felt like I didn't know.
Well, the thing is, it's like half my.
And I felt like I should.
Which sucks because I have like a few 700s.
But nobody told me. I was just happy with the game.
What's the one level?
Right, a lot of my friends.
That's what I felt.
Because like I'm.
No, that's
Because you know like.
No, at this point I was like, no, I won't. I got ripped off.
I was surprised they
Yeah, there's a test for class and
Wow.
if they fail
I'm sure
one
it'll be okay.
vocab, they have to come here.
Not to do
For
some
math,
other work.
yeah, for math though, they don't care.
They
Because
don't care about it.
either you're gonna get it or you can just because it's still
Well, it helped me a lot because I still had to do like my English so with that. I still had like an extra player.
Oh, once in a while
Like
they
the weeks are
do
really
math, it's
hectic, I
like,
just won't
they
take
piss
it.
off the
But then the
staff.
weeks, you know, most of the other weeks I try to do
But it's
something
really not hard to
at
memorize
least 10
40 words.
hours.
compared to doing it with your
No, not really. I like, I go out with my family, I go out.
No, I mean, on hectic weeks, you just don't have to.
I'm practicing my
I got like GSRM.
That's pretty good.
I was writing it,
But
and I was
only
like,
if
I was like
you're
writing for it.
I
love it.
And I was like, my work was already okay, right?
And
It's right
doing
okay,
this
and
too.
she was, yeah. I was like,
Mine's not
I
bad.
just got it all, and just said you're writing this stuff, and I'm like, you're doing my stuff.
My sense is that
It's really not bad.
to do something different than my sense of
No.
only trying to get something only in work.
Alrighty.
Let's start up again. I want to talk about fixed effects models more generally. They invaded econometrics about 20 years ago and have yet to make it to the kind of standard tool set for a lot of education research and a lot of developmental psychology. It's difficult to understand, but that's the case. And they're an extremely powerful and underutilized method for reducing bias from hard to measure or impossible to measure factors. We did state fixed effects in Hanashek and Raymond. There are individual fixed effects, family fixed effects models, which are comparing siblings. Individual fixed effects are comparing individuals with themselves over time, just regular change models. Classroom fixed effects, which are really just comparing classmates with one another and not within a classroom, not across classrooms. School fixed effects are controlling for any school differences. These fixed effects models are easy to implement. In Stata, XT-reg is the regression procedure that controls for, that allows you to do fixed effect adjustments. Equivalently, fixed effects just amount to adding dummies for each, and could be individual in the case of individual fixed effects. You have change models for each family, for each classroom. Etc. So if it's, state fixed effects, adding dummies, one per state, is all fixed effect adjustment does. If it's a school fixed effects, adding a dummy variable for each school that you've got gives you fixed effects. Gives you the same thing as what Stata would give you if you ran XT-reg. And if you think about it, and we'll talk about this right away, adding dummies is just essentially adding a different intercept for everybody, right? So that's all fixed effects amounts to. So let's do an actual example to see how this might work. Let's suppose next week we're going to have a reading with childcare quality as the independent variable and child outcome, some sort of cognitive or behavioral outcome as the dependent variable. Suppose there are two kinds of parents. And this comes out of Emmett Laroe's work. Helicopter parents and natural growth parents. Annette doesn't call them helicopter parents, but natural growth. This is how SES produces different kinds of parenting regimes. It's not completely confounded with SES, but it's certainly correlated with it. Helicopter parents, you know who you are. You're hovering over your child all the time. Natural growth, on the other hand, is a totally different philosophy, especially for younger kids, where you want to let them play, let them figure out how to make friendships and so forth. And that requires relatively little supervision, but with the belief that that's really what's best for kids, especially at younger ages. Okay, so suppose you have these two kinds of parents, and suppose you don't haven't measured what kind of parent, and you're just looking at the relationship between child outcomes and child care quality with a sample that involves both kinds of parents, right? And suppose helicopter parents tend to opt for somewhat higher quality child care. And that child care quality has some modestly positive relationship with the outcome that we're interested in. Suppose, on the other hand, that natural growth parents tend to opt for lower quality child care, and again, there might be a positive relationship between child care quality and child outcomes, but it's a pretty modest one. So if we don't realize that there are two different kinds of parents, this is obviously a very simplistic example, and run child outcome as a function of child care quality. Then we're going to have OLS give us the best single line going through these kind of points, and it might look something like that. Right? Hard to know what the best fitting line is going to be, but that's probably it. But in fact, given that we know that there are these two kinds of parents in this example, we should really be recognizing that the relationship between child care quality and child outcomes is a lot flatter than what the naive OLS line is going to give us for an estimate of beta 1. In some real sense, the relationship is a lot flatter, although it's still a little bit positive, but we just haven't estimated the right equation to produce what the real slope is. Right? So how do we, what equation would give us what we want? Suppose we could measure not only child care quality and child outcome, but also parent type.
We just put a dummy in for parent type.
Yeah, so if we estimate outcome equals C plus D1 child care quality plus D2 weather helicopter, right, if we really know whether they're helicopter parent or not. You know, whereas before we had B1 being the bias slope, now we're going to be estimating an intercept for the natural growth parents, a different intercept, C plus D2, for the helicopter parents, and we're going to estimate a common slope in this. If we estimate this, we're forcing D1 to be the same for the two groups, but we're allowing for an intercept difference. Right? We could think about putting in another interaction term between weather helicopter and child care quality to allow for the possibility of a different slope. But let's not do that and just say we're allowing for a different intercept. Alright? And what we're doing now is forcing our estimate of child care quality to be based on variation within the group of natural growth parents and within the group of helicopter parents. That's all putting a constant term does. Right? If it's this specification, we're forcing these slopes to be the same, but we're allowing the heights of the lines to differ. So just by putting in further helicopter, we're forcing this estimate of D1 not to cut across the two groups, but to be based on within group variation between child care quality and the child outcomes. And that's, in this case, a much less biased estimate of what the effect of child care quality is on child outcomes, because it's being forced to fit D1 separately within these two groups and then getting what amounts to an average for the estimate of D1. So that's parent type fixed effects. It's a very simple example, but we're forcing our estimate of some other relationship, child care quality and in this case child outcomes, to be based on within group variation. And that within group variation is all fixed effects is about. Alright, so no big deal, right? But now suppose you had child care quality and child outcomes available for siblings within the same family. Alright, so for family one, let's say one sibling had kind of medium level of child care quality, somewhat high level of child outcome, and sibling two had higher levels of both child care quality and child outcomes. that's family one. Family two, if you have a couple siblings, they might have lower levels of childcare quality and lower levels of achievement, but it's still the case that as you go from one of the siblings to the other, with the second sibling having a higher level of childcare quality, you know, could be, this might be sibling one and this might be sibling two, it doesn't make any difference. Within the same family, you're getting variation in childcare quality and you're getting variation in child outcomes. All right, family three, might have variation in childcare quality, but not much variation in child outcomes. Right, so different colors are different families, and in a data set you might have hundreds or even thousands of families with siblings. So think about the generalization. What would our equation look like if it were family fixed effects? So family fixed effects model would have the outcome as a function of childcare quality plus what?
For each family.
Okay, plus F2 whether family one, right, there are two kids in family one. F3 whether family two. So you can't include, it's all but one dummy, right? If all the kids are in a family, then it wouldn't work to have a dummy for all families, but if you have all but one, that's doing the same thing. It's, if we don't have interactions between family dummies and childcare quality, we're forcing the slope to be the same within families, but we're just getting what amounts to a kind of average slope. It's not going to be, you know, it's fairly steep for S1 and S2, but it's flatter, I'm sorry, for family 1 and family 2, it's flatter for the third family, but we're forcing all the slopes to be parallel. So we're going to be under-predicting sometimes and over-predicting other times. But these parallel lines are going to have an intercept that corresponds to the omitted family. Let's say we omit family 3, so the intercept is going to be up here. I'm sorry, this is E. And then this is the difference between F2 is the coefficient on the dummy variable for the family 1, which is going to be the shifting constant for family 1 versus the omitted family. F3 is going to be a shift from the omitted category for family 2. And then the common slope, we're forcing it to be the same, is going to be F1. Right, so why is this such a wonderful thing? Well, let me ask you, why might this be a wonderful thing? in what way are we reducing bias from hard to measure factors?
You're basically controlling for differences between families.
So any cross-family difference that might lead to a selection of different child care quality and different levels of child outcomes is not a source of bias here. The only information that you're using to estimate the relationship between child care quality and child outcomes comes from within each family. So there's no family differences that are coming into this calculation of the relationship between child care quality and child outcomes. It's an enormous advantage. It's controlling not only for things that you might be able to measure, like income differences or education differences, but it's effectively controlling for cross-family differences in things that are impossible to measure. You're just not using any cross-family variation. You know, if you didn't put in the dummies, then you'd force some regression line best fitting through the points, and that would rely on within and across family variation. But if you've got all these dummies here, every family has its own intercept. And the common slope that you're estimating is kind of an average of all these within family slopes.
Greg, there is the assumption though that if there is a family fixed effects, that each child is being treated the exact same way, regardless if you're firstborn, secondborn, thirdborn.
Any within family variation.
Okay.
Right. It's the same thing that Kelly was pointing out about the state bias, right? So, you know, if family one is favoring its firstborn, or its secondborn, right? Better child care quality, and there are probably a lot of other things it might be doing that might boost the achievement of a child that it favors. That's trouble, right? Because then what seems to be a child care quality effect here could be a function of any number of other things that come from favoring a second-born child. So, you know, if there are within family differences that you measure, that you can measure, you know, sometimes birth weight is producing an effect on child outcomes that might be related to compensatory, you know, let's put this child in higher child care quality to compensate. If there are explicit variables that, or maybe you've got information about child-specific parenting practices, right? You'd want to control for those. Then that would give you this child care quality, child outcome estimate adjusted for within family favoritism or birth weight differences or, you know, other things. So it's not a cure-all, but the fact that if you think about why do different families end up with different child care quality? You know, it's a complicated decision. It's going to be determined by all sorts of things, many of which are impossible to measure, many of which might also be affecting child outcomes, right? And any sort of cross-family difference in the determination of child care quality that's also associated with child outcomes is not a factor here. That's been eliminated as a potential source of bias in our estimates, because we're only focusing on in-family variation. Everybody see that? So whenever you have siblings in a data set, think about whether you can take advantage of family fixed effects. Sometimes you can't. I mean, sometimes, let's say you're interested in family SES and its relationship to child outcomes. If you think of SES as a fairly persistent characteristic of a family, it's going to be the same for the kids in the families, right? So you're not going to get any variation in SES that you can relate to variation in child outcomes. So it doesn't work for persistent family characteristics. But any child-specific measures, adding family fixed effects or estimating a family fixed effects model is a very powerful control for cross-family omitted variables. Classroom fixed effects. Now suppose that you were estimating a relationship between beginning of year child behavior and end of year child achievement. Kids are ending up in different classrooms. Parents are selecting into different neighborhoods or forced to live in certain neighborhoods that will determine in part what kind of classrooms they end up in. If you control for classroom fixed effects, then you're estimating these relationships only for the kids within the same classroom. Right? So you're controlling implicitly for any cross-classroom differences, which is controlling not only for school resource differences, but it's also controlling for a lot of family factors as well that lead parents to end up sending their kids to different schools. What sort of a difference might this make? If you, there's a famous Head Start article by Curry and Thomas. They have a receptive vocabulary score of children as a function of whether they were in Head Start and a bunch of family control variables, family income, maternal, test score for the mother, family size, all sorts of things. Without family controls, so if you just estimate whether attended Head Start 1-0, predicting to receptive vocabulary, you end up with these are separate effects for whites and blacks. -5.6, standard error 1.6, and for blacks plus 1.0, standard error 1.2. Without. Thank you. Without family controls. So, looks like kids going to Head Start do worse. Extensive controls, and we're talking 50 or 60 of them. Extensive family controls, you end up with minus 0.4, standard error 1.4, and plus 0.7, standard error 1.1. This is Curry and Thomas 1995. All right, so you give it the old college try with as many family variables as you can pull together. It doesn't look like Head Start is having any effect at all. But this data set happened to have, it's organized, this is the NLSY, it's organized around mothers. So many mothers have multiple kids. Sometimes you've got kids who were in Head Start and sometimes they weren't. And they've got different PPVT scores. So if you have family controls plus family fixed effects, this is also known as sibling fixed effects. Now you end up with plus 5.9, standard error 1.5, and plus 0.3, standard error 1.4. So now it looks like this is PPVT scale, I think has a standard deviation of 15 or 16. Is that right? Mm-hmm. Okay. So now it looks like, at least for whites, Head Start is having about a third of the standard deviation positive impact on this particular test score, receptive vocabulary. But not for blacks. Yeah.
So on these really big data sets, how do they connect the siblings? What does that look like? Do they connect ID numbers?
Yeah, there's a family ID.
There's a mother's ID for NLSY.
Yeah,
And then
it's unique. All the kids that a mother will have the same mother ID.
I see. And then do they have individuals' IDs as well? Student IDs or?
it's usually mother ID and then some number. So first child will be like mother ID is 201, child ID will be 20101. And then the next child, her second child will be 20102. And so on.
And to run these fixed effects models with XTReg, you just put in the family or the mother's ID, right? That you don't have to put in all these dummy variables. It's just telling it that that's the fixed effect, and it will produce those numbers in this case. Now, you still have to worry, why was it that the same mom is sending one child to Head Start, but another child not to Head Start, right? What is it that's producing that difference? And you know, if it's purely random factors, then it's almost like you've got a random assignment experiment. But if it's not, if the parents are engaging in strategic behavior and deciding that certain kids need Head Start and others might not, you need to be measuring those differences to the extent you can and controlling for those differences. So this this model should include not just kind of general family variables, but also child-specific variables that might be associated with selection in the Head Start. So there are yet other designs that are a bit more convincing. David Figlio has an article. He's got data from the every kid in the state of Florida between, I don't know, 1990 and 2000, well, it's current, including information on whether the child attended Head Start. You know where the child lived each year, and you can get data on where Head Start centers were. each year, right? And Head Start centers come and go across the years. So even if a family doesn't move, they could be living near a Head Start center when a particular child became age eligible to attend Head Start, but not be living near a Head Start center when another of their children became eligible to attend Head Start. The family might be moving and not being near a Head Start center at the time one child was eligible, but near a Head Start center when they, so there you can take advantage of distance to Head Start center as a way of trying to identify these Head Start effects. So that is done in an instrumental variables model that we'll be talking about shortly, but I don't want to do that now. So basically, you want to make an experiment out of the regression. We talked about this before. You really want to identify a causal impact of child care quality or of attending Head Start. You would like to be able to randomly assign kids to different child care quality or to Head Start or not. That, if this is a random assignment, doesn't make any difference what the other variables are, because random assignment ensures that child care quality is uncorrelated with any of the other stuff. So the other stuff can't be biasing your estimate of something that's randomly assigned. But we often don't have random assignments, so we want to try to make a regression as close to an experiment as possible. And one way to do that is with tons of control variables. An additional way is with family fixed effects, or classroom fixed effects, or state fixed effects. But you still have to ask yourself, in this case, within a given family, why is it that there's any variation in your independent variables of interest? Why is it that some kids end up in higher child care quality than others? Why is it that some kids in the same family end up in Head Start and others don't? But
is there anything stopping you from doing a sibling fixed effect with the classroom fixed effects, or multiple fixed effects in the same equation, or is that a little too much?
It depends on whether there's a nesting in the data, right? So are siblings ending up in the same classroom, right? If they're always ending up in the same classroom, then it's going to be redundant to put in classroom fixed effects. Once you put in a fixed effect for families, so this is important. If you think about this variation, if I just have one sibling, that family isn't going to figure into my estimation, right? There's no variation across child care quality and child outcomes to take advantage of. So if you put in family fixed effects, the only families that are contributing variation that you're explaining to get this common slope are families with multiple siblings, right? And that's a cost, because you won't be able to say anything about single child families. They can be used, to estimate these kind of equations, but once you go within a family, you can't. If both siblings are in Head Start, or both siblings aren't in Head Start, that's not helping either, for the same reason. So a cost is that you're kind of drilling down and taking advantage of a much smaller amount of variation than would be the case if you were going across families. But the idea is that the benefit more than outweighs the cost. So I didn't write down the R squares from this article, but it could well be, these are made up R squares. If you have extensive family controls and aren't doing family fixed effects, you're going to get a lot of explanatory power. You might get a 0.35, let's say, R square. Once you go down to family fixed effects, and you're only looking at variation within a family, so all the kind of explanatory power that comes from something like mother's education level disappears when you look within family, because the mother has the same education level for all the siblings in the family, right? So you're not taking advantage of that variability at all. So you might get like a 0.03 R square from a family fixed effects model. But remember the golden rule: bias is everything. Explain variance almost nothing. And measurement. Not so much. So now I'm talking about the explained variance, right? The fact that you've got an R square of 0.03 versus an R square of 0.35, who the hell cares? No, you have arguably reduced the scope for bias by an enormous amount by focusing on within family variation. And bias is everything. So there are still people that think, you know, if you don't have an R square that's, that your goal should be to try to explain your outcome. Receptive vocabulary in this case. That's not the goal. The goal is to get an unbiased estimate of Head Start attendance on receptive vocabulary. It's a totally different goal. Who cares if the R square is 0.03?
What about, okay, to play devil's advocate
Sure.
a little bit, what about if, let's say you're someone like Deborah who thinks that we're just not measuring childcare quality in a very good way, then wouldn't that affect our estimate?
That's the measurement, not so much, right?
Right, but.
No, and that's the third part. Yeah, I tried to find out if Deborah's really worried about measurement error in receptive vocabulary. Measurement error in receptive vocabulary won't affect your estimate of the impact of Head Start.
What about, your childcare quality variable?
Measurement error in an independent variable is more problematic because it can typically bias your estimate down by the extent of measurement error. So measurement error is always something to worry about. The fact that, you know, if you think about the Hanishek and Raymond, they were doing a change equation, and a change in something often has more error than a simple level of something. So that can compound the problem. You know, for something like Head Start, differences between siblings, it's probably reasonably reliably reported, sibling specific. But you know, if it's something that has error in it, you have to worry about that. If you know the measurement properties, if you know how unreliable childcare quality is, let's say its reliability is 0.6, okay, which is not a very good reliability score. There are ways of adjusting the coefficient that you get for the unreliability. it's this, again, Stata has a procedure for it where it's EV. I'm looking at data. It's, I can look it up, but anyway.
All my stuff is incredibly reliable, so
Right. It just allows you to plug in what the reliability is, and then it corrects the coefficient. And you know, it's just proportional increase to the lack of reliability. So if you've got a reliability of 0.6, you might get a coefficient increase of 40% or something like that. So measurement error hurts you unless you know a lot about its properties, in which case you can adjust for that. Okay, so everybody see this? It's hugely important. And it's baffling to me why. Oh, so this is the fixed effects versus random effects, right? You know, in a if you are estimating this with random effects, you're taking advantage of both within and across family variability, and you're just allowing this coefficient not to be fixed, but to vary across the sample. And that doesn't do anything to address the bias issue. You know, it might be a more realistic way of thinking about the model, that there really isn't just one quality effect that is variable. Fixed effects, you know, is this totally different kind of adjustment. And it's confusing in HLM because they use fixed effects in a different way sometimes. I'm talking about a model where we're looking at some kind of what amounts to difference between siblings, between classmates, and that's the fixed effects that reduces the bias. So sometimes fixed effects means this is a fixed number, and sometimes fixed effects means this whole different, we're looking at it a totally different way. And you get these discussions where people are presenting HLM and they say, well, this is fixed effects, and people in the audience say, that's not fixed effects. And it's because they're talking about, you know, whether this is fixed across people in the sample, or this is a totally different way of structuring the estimation to take advantage of within something, family, classroom variability.
So then why do people use multi-level models if fixed effects are so much better?
The fact that you have data from different levels, classroom and student, for example, leads to not bias problems, but problems with getting standard errors right. And multi-level models fix that problem. They take into account the fact that there's a classroom level and individual level. There are other ways of adjusting standard errors for multi-level problems, and Stata, you know, the Huber-White standard error is all about that.
When I did my master's, we never learned fixed effects. It was all about multi-level models.
Exactly.
What about allowing the effect to vary across groups?
I'm allowing what?
Like with HLM, you allow the effects, you do a random effect, you allow the effect
Yeah.
to vary across groups.
Yeah. it's still not addressing bias issues the way fixed effects.
But I mean, that might be a justification people might use.
Yeah. You know, and I'm happy for them, but I'm not gonna believe anything that comes out of their papers. Now, it's just,
I don't know, it was John Willett, he's pretty good at statistics, he's all about,
John Willett's one of the best,
yeah.
but it was the next semester that he was getting into fixed effects model. And this is that time. So let me say, I can talk about multi-level models more systematically at a future point. Let me just go over the Wong, Cook, and Barnett article. It's easier to go through than Raymond and Hashek and Raymond. Do I push it once, Taya, or twice again?
Just push it once. Not sampling, push on, yeah. And it takes 60 seconds to warm up.
Alright, yeah, good. Alright, so this is regression discontinuity. We've talked about spline models, and spline models are essentially what regression discontinuity models are all about. This is looking at the effects of state pre-K programs on achievement. They have 5 different states that set up pre-K programs, spent very different amounts of money on them, had different characteristics. These are teacher-child ratios. Some are half day, some are full day, different levels of teacher education. But it's worth taking a look both within each of these states as well as getting some sort of average, just to get an idea of how effective or ineffective pre-K programs are for boosting achievement outcomes. What makes this analysis convincing, normally if you had data on kids from these states, some of them attended pre-K, some of them didn't, you'd really worry about selection bias. Why is it that some families were sending their kids to pre-K and other families in seemingly similar circumstances weren't? That's the potential bias story that might lead you not to trust even an excessive or extensive family control model estimating effects of pre-K. So what drives this and makes it more convincing is that in all 5 cases there was a birthday cutoff for eligibility. If kids were older than some date, fixed date, they could get in. If they weren't that age yet, they couldn't get in until the following year. And they were able to test all these kids on the same test. Both the kids who just spent a year in pre-K as well as the kids who were about to spend the next year in pre-K. Right? So if you think about it, in the limit, you've got kids who are just a day apart in age. But that day made all the difference. Either they got in or they didn't. And if you test those kids at the same time, one of them had just spent a year in pre-K and one of them hadn't because they just missed the cutoff. So that's the idea. That difference in the outcomes is going to be a pretty good estimate of what pre-K impacts are. All right, it's never quite that simple. Here's to what extent you actually followed the birthday cutoff. So you can't really see this very well, but if you centered the data right on the cutoff, kids who were too young, none of them in the sample had been in pre-K at the time of the test was given. And then all of a sudden you shoot up to 100%. The kids in the sample were in pre-K, and then there's a little, I'm not sure what's going on up here, but it's not very many people. In some of the other states, you get a little bit worse compliance. Right? In New Jersey, there were some kids, I think each bar is a kid. So you had some kids getting in even though they were too young. And you had some kids who weren't in even though they were old enough. But across these samples, the number of kids was very small relative to the total number of kids. So by and large, compliance was pretty good. South Carolina, again, here's the 0 line. There were 5 kids who got in, shouldn't have, perhaps 1 or 2 that should have been in but wasn't. So anyway, there are somewhat exotic methods to try to handle this problem, but it's not much of a problem because there aren't many of these kids. So the equation is really just a spline equation where you want to know whether they were eligible for pre-K or not, and then you want to adjust for their age. So test scores are growing with age, and you want to know whether they're jumping up at the point of eligibility. And here's the kind of result that you get. Can't remember. Oh, this is New Jersey. Okay, so this is New Jersey using the receptive vocabulary test that was used in this NLSY based Head Start analysis. I always draw the dots really closely conformed. This is the real world, right? Data mass. These are all the kids and the variation in test scores who had not yet reached the birthday cutoff. Here's the mass for the kids who had. Plenty of kids who had were scoring below kids who hadn't. But the real question is there any sort of jump right at the point of discontinuity, at the point of eligibility? So if you run this simple model and allow just for a constant term to shift, you get this line fit through the not yet old enough group, and then it jumps up to this line for the old enough to be in pre-K group. So it's this difference that's the estimate of the effect of pre-K. Okay, now this is using, remember how we started out and said you really want to look at kids who are just 1 day apart in age? The 1 day apart in age, those are the kids on either side of this line. And there aren't very many of them who are literally within a week of one another. Here, to estimate the slope, you're taking kids who were half a year, 3/4 of a year too young, or half a year, 3/4 of a year beyond the cutoff. So you really want to have some method for focusing the estimate of the jump on a closer and closer group to this cutoff point. So there are various techniques for doing that. Just descriptively, I'm sorry, this is a linear plot. And then there's a fancier, more data-intensive way of fitting lines that's called LOS, which is a kind of a local weighted average estimator. So it's not forcing a line, but it's getting a slope based on points close by to where you're estimating a relationship. It looks pretty linear, and it looks pretty linear. But again, you can test for that kind of thing. And you can, those were lines that were fit. You can estimate quadratics. You can estimate cubics, right? You really want to make sure that what's happening around the cutoff point is as well described as possible. And it turns out a lot of times just a linear relationship does fine. And if you go to actual estimates, all right, so this is Michigan. For the receptive vocabulary test, a quadratic form ended up fitting the best. So on either side of that line, you allow for a quadratic, and you want to know what the projection of that quadratic is right at the point of the cutoff. Standard errors are in parentheses, so nothing's happening, right, with the PPBT test scores, depending upon whether kids were old enough or not to be in the Michigan's pre-K system. So insignificant linear effect, insignificant quadratic effect, insignificant cubic effect. If you truncate the data down from being 2 years in length, a year before, a year after, to just 6 months on either side, so you're getting closer and closer to the cutoff, you're also getting an insignificant result. Bandwidth, there are fancier ways of estimating the function around that cutoff point, and this is different ways of characterizing the distance. Again, nothing going on that's significant. You can also, if you worry about this fact that there's a little bit of slippage, some of the kids who were too young got in, some of the kids who were too old didn't. You can do kind of a two-stage procedure where the first stage is using what their birthday actually was to predict whether or not they were in pre-K, and then use the predicted pre-K participation as its, to look at its impact on PVT. This is instrumental variables, but it doesn't make any difference. All these things are insignificant. Some are positive, some are negative. The best guess is that the Michigan system had no impact on receptive vocabulary. Math, on the other hand, linear model ends up fitting best, but which means if you add the square term, you're not getting more action. If you add a cubic term, you're not getting more action. These are all estimates of that jump right around the point of the discontinuity, and they all look to be 2 to 2.5, as much as 3 points on the math test, right? And you've got to look to see what the standard deviation of the math test is to see how much of an effect that is, that effect size. Same way with print awareness, they have a table with the effect sizes later on. Print awareness, linear fits best. Big impacts here. Well, let me see, big. Now, to get an idea, math and print awareness have to be scaled differently because of the different standard errors they have, right? There's got to be a lot more, a much bigger standard deviation for print awareness than for math because the standard errors are so much different. So whether the effect size is bigger, we'll reserve judgment for. But the bottom line is 20 points on the print awareness scale, all statistically significant. It's a very robust finding if you go across different ways of estimating the regression discontinuity effect. Okay, and I think they go through the different states. New Jersey, there's a summary table here in a little bit. All right, so here's kind of the bottom line. They all had 3 tests. You know, this was done by the New Jersey Early Education Research Group, and they worked with the states, made sure they tried to adhere to the birthday cutoff. All the states agreed to do the same tests, so you had PPBT common across states. The math test was common, the print awareness test was common. And what they show here are these coefficients that come from, I think these are coming out of the instrumental variables column, but it's, you know, it's pretty similar across those columns. So Michigan had a -2.2 insignificant. That translated into effect size of an insignificant -0.13. Michigan had this significant math coefficient, 2.07, which translates into an effect size of about a half a standard deviation. So kids in the pre-K system seem to have about a half a standard deviation more math achievement than the kids who are just barely too young to get in. Print awareness, the 25 that we saw before, that translates into more than a 1 standard deviation increase in print awareness. But that's just Michigan, right? New Jersey had a positive effect on PPBT, a smaller effect on math than Michigan, and a considerably smaller effect on print awareness. Oklahoma, you know, you can look at these scattered patterns, but you know, down here is the weighted average. They could have done a significance test on this, but they didn't. But the average effect size for PBT is about 1/6 of a standard deviation. A lot of variability. For math, it's about 1/4 of a standard deviation, and the real impact came for print awareness, which was 2/3 of a standard deviation. So for print awareness, all the states but Oklahoma produced a significant impact on print awareness. In Oklahoma, it must have been a smaller sample size. The estimate was pretty substantial, 0.42, but it was not statistically significant.